Hi, this is a video of trapezoids and kites. We've been talking about different shapes. If you haven't watched parallelograms, rhombus, square, or rectangle, go and watch those now because they will help you with proofs. We're going to kind of talk about trapezoids and kites in that way as well. So the definition of a trapezoid, and let me just do this. A lot of people get this wrong because they are like, well, isn't a square a trapezoid? Well, the definition says a quadrilateral with exactly one pair of parallel sides. So only one pair is parallel, the others are not. So a square is technically not a trapezoid. It doesn't say at least one pair of parallel sides, it says exactly one pair of parallel sides. So it cannot have more than one. And then also the parallel sides are called bases. So these are called bases, B-A-S-E-S. And the non-parallel sides are what you call legs. Where have we seen that before? On a right triangle, it has legs. So the bases and then the legs. So this is a base too. So, and then we have something what we call the median. So the median of a trapezoid, sorry, I'm like, what is this shape here? Of a trapezoid is a segment that joins the midpoints, so the midpoints of the legs. So it's a segment that joins the midpoint. Midpoint means that's exactly in the middle of that leg, exactly in the middle of that leg, and that segment is what you call the median, okay? Median means middle. If you found the median of different data, it's the middle number, so median means middle here, it's in the middle of the trapezoid. The median, how you find it, how you find the length. So the median, how you find the length is you take half of base 1 plus base 2. So you add the two bases together and then take half of that or divide it by 2. And divide it by 2, and then you find the median length. So here's a theorem about trapezoids. The median of a trapezoid is parallel to the bases. So here's the first theorem. If I were to do that, and let's say this is P and M. So the median of the trapezoid, so MP, is parallel to the bases, is parallel to DC, and MP is also parallel to AB. Okay, so that's the first theorem. The median is parallel to the bases. The second theorem is the length of the median is 1/2 the sum of the lengths of the bases. So that's how you find it, 1/2 the sum of the bases. So that's another theorem too. So if you were to prove that the median was 1/2 the sum of the bases, you could say, oh, then that's the median. Okay, and that is on your way to proving that it's a trapezoid. There is one specific type of trapezoid, and it's called an isosceles trapezoid. Just like an isosceles triangle, it means the two sides are congruent. So the same here, which means that the legs are congruent. So the legs are congruent of an isosceles trapezoid. And then, so the properties of a trapezoid are both pairs of base angles. So, of an isosceles triangle. Of an isosceles trapezoid, the properties are both pairs of base angles of an isosceles trapezoid are congruent. So if I were to ABCD, that would mean this angle and this angle are congruent. Those are the base angles. So angle D and angle C are congruent. And then the second property is diagonals of an isosceles trapezoid are congruent. So the diagonals of this trapezoid, of an isosceles, remember we're talking about isosceles. I guess I should write that in because now we're talking about isosceles trapezoid. The two properties are the base angles are congruent and then the diagonals are also congruent. Okay, so that is about trapezoids. Let's talk about kites. So a kite looks like a diamond. So a kite is, the definition of a kite is a quadrilateral with two distinct pairs of congruent adjacent sides. So this side is congruent to that side, And then this side is congruent to that side. Adjacent means side by side. So that is the definition of a kite. So if you can prove that the two adjacent sides are congruent, then you can prove that it is a kite. And so one of the theorems is that the diagonals of a kite are perpendicular. So the diagonal from one angle to the opposite angle, they are perpendicular. So the diagonals are perpendicular is that theorem of a kite. Okay, so we've learned a lot about shapes, and so I'm just going to do a flow chart on this one. So quadrilaterals, we learned that are four-sided figures. And then within quadrilaterals, we have a kite, and we have a parallelogram, we have a parallelogram, and then we also have a trapezoid. Okay, there's no shape that goes under kite. A kite is just a kite. But a parallelogram, we can have a rectangle, and then we can also have a rhombus. And then under trapezoid, we have one specific type of trapezoid, is an isosceles trapezoid. Okay, then within a rectangle and a rhombus, we have what we call the square. So what's really funny is that a square can have the name of, it can be called a rectangle, it can be called a rhombus, it can be called a parallelogram, it can be a quadrilateral. But the most specific name for it is a square. So that's why we call it a square. But you could call it all of these others as well. A rectangle has three names. It can be called a parallelogram, it can be called a quadrilateral. A rhombus also has three names: parallelogram, rhombus, or quadrilateral. And then a parallelogram can also be called a quadrilateral. So, but we always name shapes for their most specific name, okay? Because we need to distinguish between a square and a rectangle, a parallelogram, and a quadrilateral. Because not all quadrilaterals are squares, but all squares are quadrilaterals. Somebody, my teacher always confused me when she was like, well, all squares are rectangles, but not all rectangles are squares. Okay, true statement. Okay, so go confuse somebody out of that. Well, hopefully you enjoyed this, and thank you for watching.